We forget that the American Industrial Revolution of the 17 and 1800s was fueled by the timber industry providing raw materials for the nation. In other words, wood products. Hello again, everyone. This is Guy Hamlin with Trailkeepers of Oregon. I'm a crew leader with TKO, and this is the sixth of a series of training videos covering intermediate crosscut Sawyer information. It's important to mention, however, that this material does not substitute nor qualify for an official Forest Service sanctioned Sawyer training course. Well, here we go. The much anticipated discussion of binds, the analysis of binds, and how do we Sawyers safely plan cuts or cuts in a downed trail log. So let's get started. In this discussion module, we're going to talk about binds in general, the types of cuts for a bind or combination of binds, and the use of wedges to control a bind. We will cover hazard tree scenarios in greater depth in the next discussion module, hazards and trail crew safety. The Forest Service defines a bind as the two major components of a bind are compression and tension. The directional pressures of compression and tension determine the sawing technique and procedure used to release them. Now, compression and tension are forces on a downed log and are based on the force of gravity and how gravity interacts with that log. Those forces are dynamic and will change during a saw cut. The Sawyer team goal is first to identify the forces at play and then plan a cut or cuts to safely release that energy. Determining the binds in a downed log can be the most technically challenging part of the OLEC process and the cut plan. But this is also the most rewarding part of participating in a saw team. Building a plan based on the objective and then making it happen. Top bind is the result of gravity acting on the unsupported section of the log between two supporting bearing points. This is the most common downed log scenario. These compression and tension forces decrease as you get closer to the bearing point. The size of these forces depends upon the weight, size of the log, and the distance between the bearing points. Start your top cut and get as deep as you can before pinching your saw. If you get in deep enough with your cut to insert a wedge to control the bind, you may not need to underbuck. On smaller logs, underbucking will normally be required. However, smaller logs, when near the ground, can be lifted with a lever and fulcrum to change the bind. The fiber of a log, whether it is dry or green, will have a big impact on how deep in a bind cut you can get before pinching the saw. As you gain more on-saw experience, you will develop a feel for the bind forces and when you will need to wedge or pull the saw out and start an underbuck. A small undercut is useful to help with a clean release. The sapwood is very strong and will hold the log together. A small katana boy saw can often be used. With top bind, use wedges of different sizes as soon as you can. Start out with smaller wedges, then, when you have a saw clearance, use larger wedges. It takes a few moments to insert wedges to control the bind. It might take hours to cut or chop out a pinch saw. Bottom bind is caused by gravity acting on the unsupported section of the log. Depending on the size, length, and condition of the fiber of this cantilevered log, There can be an amazing amount of energy in the cut, and the cut will be very dynamic. Prepare for a lot of movement. Also, be wary of torsional binds on the log during the release cut. It might want to roll. In some situations, the binds may be what we call multiple and severe binds and require considerable attention by the saw team. If physically possible, some sawyers will go well out of the trail corridor and make a cut just to release some energy in the bind at the trail corridor area, particularly at a bearing point. This type of cut and bind can cause a barber chair or alligator mouth release, some with a lot of energy. Be wary and always consult with more experienced sawyers if necessary. Because of the multiple severe binds, these cuts could be a C cut. When possible, make the cut at a bearing point, and there will be no need for an undercut. If you can, construct a bearing point by inserting wood or rocks under the log. Small diameter logs can be used as levers with a fulcrum, and they sometimes can help to lift the log. Side binds can be very challenging for a sawyer team. Often in a green log, there is a lot of hidden energy that can surprise a saw team. Many times, a cut must be planned well away from the trail corridor just to release some energy. Look for bearing points that indicate side bind. The energy is released on the tension side of the log, so cutting operations must be done on the compression side of the log. Establish safe escape routes and a safe area for the saw team. Cutting next to a bearing point allows for the controlled release of energy, and often a sawyer can stand behind a tree for safety. Initially cut on the compression side to remove material, which allows for the log to move and release energy as the tension side of the log is cut. Be wary of kerf closure and pinching the saw. Mild side bind that is not identified will close the kerf and pinch the saw. It is very common for side bind to appear during a cutting operation, especially if the log slides down along a standing tree where the butt of the tree is larger and increases the side forces on the log. Did I say that side binds are often more complex and therefore more dangerous than simple top or bottom binds? Don't hesitate to consult with more experienced sawyers when severe side binds are involved. The weight of the log above the cutting area causes compressive forces acting on the length of the log. Be wary. These logs may want to roll or slide after the release cut. Some sawyers use properly sized ropes to control the cut piece after the cut, but that is a topic for an advanced discussion. End binds generally require the use of a lot of wedges to keep the kerf open. Notice the ditch and bark below the saw, and the assistant watching the kerf on the opposite side so the sawyer knows when she is getting close to the release. Multiple binds are a combination of two or more binds. These binds can move and change as you cut. Side binds will change to top or bottom binds as the side bind is relieved. Bearing points can also change. Don't overlook torsional binds, which are sometimes hidden. Constantly monitor the kerf. It's your key indicator window into what is happening with the energy in a log. Multiple binds add complexity to the cutting operation. If the kerf is not opening according to the cut plan, stop and reassess the cut plan. If some of the multiple binds are severe, in other words, a lot of energy in the bind, this may make the log a C log. This has been a fairly high-level discussion of binds. Determining binds at play in a log is technically challenging. Actual saw and log out experience with a skilled saw team will help you get a better feel for the types of binds in a log, especially as you see the energy being released as the log is cut. There will be more information about binds during a Forest Service certification class. Now we're going to discuss a bit about the types of saw cuts you can make in a log. These are the more common types of cuts the Sawyer team will use. Straight cuts are perpendicular to the length of the log. They are a very common cut for most log situations. Compound cuts are more technical, but can be very effective for controlling the cut piece during the release. Offset cuts are generally necessary to protect the saw during the release. They require a bit more skill for the saw team. These are the most common types of cuts for a Sawyer team. We will discuss some other types of cuts during the Forest Service certification class. Now let's discuss the cutting sequence for a saw team. Okay, there's going to be a lot of information here, but basically this is a review of your cut sequence to meet your OLEC objective for the log. In determining your cut plan, as a team exercise, review the binds, pivot points, support structures, and bearing points. Review your safe areas. Does your tentative cut plan address the level of complexity in the log? Don't be afraid to go well off trail to remove weight, that is, energy, from a log so your corner cuts will be safer. Use limbs or the remaining tree to secure your cut pieces. A saw team should focus the cut plan to address the complexity in the logs and to remove the energy in the log or logs in the most controlled manner. This will be a classroom exercise to talk through the cut plan and cut sequence. There is a lot of risk with this log, plus a lot of energy stored in the binds. By the way, this is a C log. Steep slope, detached root ball, multiple severe binds, large log. There already is a no work area this side of the log because that root ball could come down at any time. These are the same pictures from earlier in the safety presentation, but a very useful reminder of planning ahead before your release cut. The use of wedges is very important with a crosscut saw. You can always remove a wedge as the kerf opens, but it is very difficult to install a wedge once the kerf closes. Homework question: how many wedges should a saw team wedge? Homework answer: as many as a woodchuck can chuck. Okay, I heard that groan. Actually, a saw team should have a good variety of 6 and 10-inch wedges, certainly a minimum of 4 each, and is dependent on the size of the logs to be cut. Include a set of hanging wedges or tie wedges to control a torsional bind. It is generally not a good practice to use an axe to control torsional bind. This is that angry mountain in Washington. I'm actually surprised the saw is in this far with a tight bind log. Come join us for some crosscut saw log out fun.